Hello everyone, welcome to the part 2 of completing all the exercises in exercise 1.1 in chapter 1.1. So let's get started. In this video we will cover from 5 to 10. And if you haven't seen the previous video, part 1, make sure you see it in the descriptions. So in number 5, we have match each numbers to a product of prime factors. And we can see that number A has already been done for us as an example. So 20 is matched up with 2 square multiplied by 5 because 2 square is equal to 4 and 4 multiplied by 5 is 20. So why not let's do the other ones. So number B, let's first do these parts and work out where they match up with. So 2 multiplied by 3 multiplied by 7. If you multiply 2 and 3, we will get 6. And if we multiply 6 with 7, we'll get 42, which is number C. So we shall match up 2 with 42. For number 3, we got 2 square multiplied by 3 square multiplied by 5. 2 square is equal to 4. 3 square is equal to 9. So 4 multiplied by 9 is going to be 36. And if we multiply 36 with 5, let me show you in rough. 36 multiplied by 5, we get, let's see here. 180, which means we match up 3 with a 180. Next we have 2 multiplied by 5 square. 5 square is 25 and 25 multiplied by 2 is going to be 50. Obviously speaking, the last one to be matched up with is going to be with 5 because these are the ones which are left. And even if I think like no, let's still check. So 2 cubed multiplied by 3. 2 cubed is equal to 8. 8 multiplied by 3 is equal to 24. Number 6, we have to find out the product of each of these prime numbers. So let's first see what 6a is. 3 square is 9 multiplied by 5 multiplied by 7 is equal to 45 multiplied by 7. And 45 multiplied by 7 is equal to 35 multiplied 35, leaving 3. 7 times 4 is equal to 28. 28 plus 3, we get 31. So our answer is 315. Now let's do 6b. 2 cubed multiplied by 5 cubed. We know that 2 cubed is equal to 8 and 5 cubed is equal to 125. So what will be this product of them together? So 8 multiplied by 5 is 40, leaving the 4 here. 8 multiplied by 2 is 16. Add 4 to it to get 20. Then leave 2. 8 multiplied by 1 is 8 and 8 plus 2 is 10. So our final answer is 1000. Now to number E. 2 square multiplied by 3 square multiplied by 11. 4 2 square is equal to 4, and 3 square is equal to 9. If we multiply 4 and 9 together, or you could multiply maybe 4 and 11 together, or 9 by 11 together, but I'm going to multiply these two together to get 36 multiplied by 11. And now let's do the rough. In case you're wondering why did I do this like this instead of the longer method, there's actually an easier method how to do these multiplications faster. So I've made a short about it. The links are going to be given in the descriptions. Now number D, 2 to the power of 4 multiplied by 7 square. 2 to the power of 4 is 16, and 7 square is equal to 49. Now this is really hard, as these both are very big numbers. So in rough, we could multiply these. Instead of using the easier method, there's actually another method here as well you can also try. I haven't made a short about it yet, but when I will put it in the descriptions. So the answer is 784. Showing you once more in the more international method, or the one you guys already know of. 9 multiplied by 6 is 54. We put 4 here and leave 5. 6 multiplied by 4 is 24. 24 plus 5 is equal to 29. Then we multiply 1 with 49 to get 49. Then we add the two together. 4, 9 plus 9, 18. 1 in hand. Now we add the 1 with 2, 4 to get 7. Same answer. Number E, 3 multiplied by 17 square. 3 multiplied by, I don't actually know what's 17 squares, so 17 multiplied by 17. 7 multiplied by 7 is 49. 4 in hand. 7 plus 4 is equal to 11. Now 17. Now we get 289. Now we have to multiply 289 with 3, which will give us 27, 2 in hand. 8, 3 multiplied is 24. Adding 2 is equal to 26. With 2 hand again. 3 multiplied by 2 is 6. Plus 8. 2 is equal to 8. So our final answer is 867. Now we are going to start number 7. Write each of these numbers as a product of prime factors. So number A, we got 28. To make them a product of prime factors, we have to find the LCM of the numbers. So 28 is divisible by 2, which gives us 14. 14 is divisible by 2, which gives us 7. Therefore, prime product of prime factors is 2 square multiplied by 7. So we got 60. 60 is divisible by 2, which gives us 30. 30 is divisible by 2, which gives us 15. 15 isn't divisible by 2, but it is divisible by 3. So we get 5. Therefore, 60 is equal to 2 square multiplied by 3 multiplied by 5. See, we got 72. 72 divided by 2 is equal to 36. 36 divisible by 2. So it is equal to 18. 18 divided by 2 is 9. 9 we can divide by 3. It gives us 3. So 72 is equal to 2 cubed multiplied by 3 square. In number D, we got 153. So we could divide this by 3. So how do we get it? A rough would be good. If we give 5, we get 15, which leaves us with 3. 3 multiplied by 1 is 3, 0. Therefore, 51. 51 is also divisible by 3. 3 multiplied by 1, 3, 21. 3 multiplied by 7, 21. 17. Therefore, 153 is equal to 3 square multiplied by 17. Next, we will do 190, and 190 is divisible by 2, which leaves us with 95. Now 95 is not divisible by 2, but is it divisible by 3? Nope. It is also not divisible by 3. But what it is divisible by is 5. 5 multiplied by 5 is 5. Multiplied by 1 is 5, which leaves us with 45, and multiplied by 5 is 45. Therefore, 190 is equal to 2 multiplied by 5 multiplied by 19. Now for number F, we got 275. 275 is divisible by 5. 5 multiplied by 5 is 25. When we subtract, we get 2. We bring 5 down, multiply 5 with 5 again, and thus we get 55 as our answer. 55 is divisible by 5, leaving us with 11. Therefore, 275 is equal to 5 square multiplied by 11. Now to number 8. Copy the table and write each number as a product of prime numbers. So you can see this table below. So I've already copied this in the copy. And we are also supposed to add some more rows to the table to continue the pattern. So there's a pattern in this. According to the table, 35 is equal to 5 multiplied by 7. 35 is the half of 70, so we just multiply 2. 2 multiplied by 5 multiplied by 7 is equal to 70. 70 is the half of 140. So we add another 2, multiply another 2. It gives us 2 squared because 2 times 2 is equal to 2 squared. 5 and 7. 2 squared multiplied by 5 multiplied by 7. 140 is the half of 280. So we multiply another 2. 2 cubed multiplied by 5 multiplied by 7. So I'm pretty sure that you guys could make your own rows in here, but I'll still make another one. So what is 280 multiplied by 2? Let's find out. 280 multiplied by 2. 2 multiplied by 8, 16, 1 in hand. 2 multiplied 2, 4, plus 1, 5. So it is 560. Therefore, we multiply another 2. 2 to the power of 4 multiplied by 5 multiplied by 7. Number 9a, write 1001 as a product of prime numbers. First thing we do is to see if 1001 is divisible by 2, which clearly isn't. Then the next prime number, which is 3, which is also not going. 5 also doesn't go. Let's see if 7 goes with this. 7 multiplied by 1 is equal to 7, leaving 3, 0. 7 multiplied by 4 is 28. 2 remaining and 1 down. 7 multiplied by 3 is equal to 21, which gives us the final amount of 143. 7 divided by 1001 is equal to 143. Now, 143 is also not divisible by 2, 3, 5. So let's check out if it's divisible by 7 as well. 7 divided by 143. 7 multiplied by 2 is 14, leaving 3. 7 multiplied by 0 is 0. Therefore, it doesn't really go. How about let's try 11 with 143. 11 divided by 143. 11 multiplied by 1 is 11. 4 minus 1 is equal to 3. Dragging 3 down here. 11 multiplied by 3 is 33. Therefore, 143 is divisible by 11, and if we divide it, we get 13. So the representation of 1001 as a product of prime numbers is 7 multiplied by 11 multiplied by 13. In 9b, we got 4004, and mind you that there are two ways to find prime factors, which is in this way, like an LCM style, and another way you can do is by using the factor tree. So whichever is more beneficial to you, you can use. But I would suggest you guys to use this one. So in number B, we can see that 4004 is divisible by 2, which gives us 2002. 2002 is divisible by 2, so 2 divided by 2002 is equal to 1001. And we just copy paste whatever we had already done for 1001. So we divided 1001 with 7, which gave us 143. We divided 143 with 11 to get 13. Therefore, we can represent 4004 as 2 squared multiplied by 7 multiplied by 11 multiplied by 13 as a product of prime numbers. For number C, 6006 is also divisible by 2, which gives us 3003. 3003 is divisible by 3, which gives us 1001. And just like before, we just copy paste what we have already done. Therefore, 6006 can be represented as 2 multiplied by 3 multiplied by 7 multiplied by 11 multiplied by 13 as a product of prime numbers. Number 10a, use a factor tree to write 132 as a product of prime numbers. So here we have to use a factor tree this time, 10a. So if we divide this by 2, your preference which one you take, we get 66. 66 divided by 2 is 33. 33 divided by 3 is 11. Therefore, 132 as a product of prime numbers is equal to 2 squared multiplied by 3 multiplied by 11. In 10b, 150, we have to show this as a product of prime factors. We could do it simply like this or this. So I think why not let's just do it like this. It's going to be more simpler in my opinion. 2 divided by 150. I'm not really sure. 2 divided by 150. 2 multiplied by 7 is equal to 14. 1 and getting 0 down. Now we multiply 5 with 2 to get 10. So the answer is 75. 75. We can divide 75 with 3 to get 25. 25 can be divided by 5 to get 5. Therefore, 150 as a product of prime numbers is equal to 2 multiplied by 3 multiplied by 5 squared. Finally, for number 10c, 132 multiplied by 150 is equal to 19,800. Use this fact to write 19,800 as a product of prime numbers. I think it would be better if we do it as a factor tree. So we had 132 and 150. 132 we can divide it by 6 to get 22. And for 150 we can divide it by 5 to get 30, I think. Yes, 30. Now 6 can be divided by 2, which gives us 3. Also 22, which gives us 11. 5 is already a prime factor. 30 can be divided by 5 and 6. Then 2 and 3. It would be better if I'd use 2 like from small prime numbers to large prime numbers, but whatever. Therefore, 19,800 if represented as a product of prime numbers is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 5 multiplied by 11, or 2 cubed multiplied by 3 square multiplied by 5 square multiplied by 11. Now that's a lot of prime numbers.